Everyone, good day to all. Welcome to the webinar with Mr. Joachim Grimm, hosted by GemAtlas. Mr. Joachim has been working with Umicore for the past 13 years. He currently provides technical service and support for decorative precious metal applications in various countries across the world. Umicore Electroplating is one of the world's leading providers of precious metal electrolytes and of selected plating techniques. GemAtlas is an online B2B networking platform for the gems and jewelry industry. We help you connect with businesses and professionals around the world. You can easily start generating new business leads through our platform. We are honored to have Mr. Joachim share his valuable insights. The topic for today is rhodium plating cost-saving techniques. There will be a Q&A button. Please feel free to enter your questions below and have them answered at the end of the session. Over to you, Mr. Joachim.
Good day to everybody from my side as well, or good afternoon mainly to India. I'm here in Germany sitting, and I want to explain you a little bit about opportunities and possibilities to save rhodium cost in plated rhodium. I want to give you an overview about how to save it just cost-wise in precious metals and how you can go for other technologies or other ways to get a saving in your plating job shop. So the point is that if you see rhodium nowadays, it's a very volatile and a very high precious metal. So I want to show you the comparison of the precious metal pricing if you see two other white precious metals. As well as I want to compare the rhodium pricing to some alternatives, what is up-to-date technical status, how to use it to have a saving. And I want to make a short way to how to save palladium or have a saving in your total stack of the plated layer. I want to go to the background data of the precious metals and his alloy, because here the main figures are hidden. So the point is that with the very high pricing of the pure rhodium, which has a very wide and light shine if you plate it on a jewellery, but on the other hand, you have the most high price if you buy it just with the precious metal pricing on the market. If you do a pure plating and you see this is a calculation, the price of 1 micron on 1 square dm layer is that costly, about 28.13 euro. But of course, mainly the jewellery industry needs this rhodium for a wide, hard, abrasive resistant layer. The whiteness, this is described in this line, is the most white one and light one compared to the other white platinum precious metals compared to like platinum, palladium or ruthenium. If you see the lightness, which is the L value 90 at rhodium, which is the whitest of the platinum metals, next would be 87 at platinum, palladium around 84 to 85, and ruthenium it's just 70 to 75. I have gold just here as a comparison, we need that later on, and I put silver as a comparison. Everybody knows how white silver looks like, and pure silver has a whiteness of 98, 99 in this calculation. So one point you have always to be, let me say, careful if you do some calculation. If you do plating with rhodium or you buy it, it's always by weight. And this depends totally on the specific element's density. So the layer density of pure rhodium is 12.4 compared to platinum, which is 21.45. So in your calculation, if it's going to the thickness of a layer, you have to calculate with the layer density. But this is all needed for the final calculation. If you compare like with palladium or ruthenium, the same calculation. How much costly is 1 micron at 1 square dm? And here, just as a comparison again, the rhodium is our status. This is where all our calculation starts. We want to compare it with the rhodium. The platinum is just, or is 82% cheaper than rhodium in the layer of 1 micron on 1 square dm. 74% for the palladium, 96% for the ruthenium. So of course we could just say, okay, we just do ruthenium, but I guess no of your clients would like the color in ruthenium as it's more dark compared to the rhodium. So what opportunities do we have nowadays? Everything has to be high quality, but as well, it should not be too costly. And with this high rhodium pricing we had in the last month, or at least the half last year, we need to do something to have some saving in that. So what is available on the market is, in the meanwhile, an alloy. Who asks you to do pure rhodium? You can do as well a layer of rhodium-ruthenium in an alloy in plating. Not just what the, let me say, others do in the master alloy, mixing lower caratage. You can do the same with plating. Even if you have a little bit higher density, 12.42, forget about this small number. It's more or less the same density than pure rhodium. And in this mixture, it's 75 to 25% is ruthenium inside. The lightness, so the white color, will still be at 89.9 compared to 19.1. So it's still much whiter than pure platinum, for example. And your client in the jewelry shop isn't able to see a difference between these colors. So what does this mean? If you have a saving of 25% metal in this alloy and you replace it by ruthenium, at the end you have price-wise a saving of 24% at this 1 micron 1 square dm, comes to a price of 21.36 euro compared to 28.13. The metal prices I took was yesterday, 7th May, and on this metal pricing everything is calculated. If you can mix rhodium and ruthenium, why not mixing rhodium and platinum? So the same is possible. Platinum, as we have seen, the density is much higher, so we reach a higher density. So the effect is a little bit buffered in the saving, but at the end, because of the different pricing, you get a result of a mixture at 50% rhodium, 50% platinum, 30% saving, as if you mix platinum into rhodium, it's easily done, still having a lightness of 88.9, because it is still quite close in the color. That's why the rhodium-ruthenium, it's just 25% mixed to reach 89 in the lightness. So it's not getting too dark that it's not visible for the client, that it's a mixture and not a pure metal. And for another step of saving, which is at least the biggest step, if you have platinum mixed with ruthenium, you have sure not that wide layer, you have a little bit more dense layer, but at the end, with 75 to 25 mixture, your price of 1 micron at 1 square dm compared to the rhodium comes down to €3.69, so it's an 87% saving. So how can this be handled in the plating actually? If you want to have a layer sequence, how to do that? So how to replace the rhodium coating, the pure one? So we got the numbers again. In this case, I took not 1 micron on a square dm. I took a more standard plating layer of rhodium, 0.1 micron on a jewelry piece. Let us say our standard stack could be sterling silver plated by pure rhodium. Comes to a pricing of €2.81 in the standard stack. This is what usually the jewelry market is selling you, or you manufacture and give it to the market. So what would be the case if you do, instead of the pure rhodium, the alloy of rhodium-ruthenium? I did the calculation with this 75 to 25 mixture. So 25% of ruthenium is mixed in, and we bring down the price to around €2.14. So it's a 24% saving. And the same you can do on your sterling silver with a plating of rhodium-platinum. Compared to the pure rhodium, we reach 30% saving and come to a lower price of €2, so it's €1.97. So with this, it's an easy way in the plating job shop. You have your standard pure rhodium plating, but instead of this, you just change your tank or make up another solution with this rhodium-ruthenium alloy plating or with rhodium-platinum. So there's nothing specific around needed. You have the same setup in your plating shop, like rectifier, wires, anodes, and so on. There are small adjustments have to be done. Rectifier has to be powerful enough and proper anodes have to be used, but the setup is the same like you are used. And you can do it either in 1 beaker, 1 liter, or you can go to 1,000 liters if you want. And then the saving will be really interesting. So this is, I say, that's the first level of saving you can do. This is an easy replacement of the one plating and using another plating to get this saving. The result for the client is not really visible. Okay, but coming to the level number 2. So why doing a pure rhodium layer on sterling silver? Your client wants to have something white, shiny, like he's used from the rhodium plating. So we give him the rhodium plating on top. But the platinum is a precious metal as well, has a high hardness and corrosion resistance. So it's the same category of precious metal what your client like to have. And if you see the same thickness on the whole sequence of plating, you can do an intermediate layer of platinum and just a pure rhodium plating on top. And you get at the final end 0.1 micron of precious metal white platinum layer. The rhodium is on top, and the saving is a huge step to under €1 at the actual pricing, and it's about 65% of saving on this actual metal pricing. So this is a big step, having one additional plating underneath. So your sequence of your sterling silver as an example, a platinum layer on top, and then your pure white rhodium on top, giving you a huge saving. And for your client, the quality is still the same. There is the abrasive resistance, there's the corrosion resistance, and it's still the white, shiny rhodium plating. But about saving, you can get additional one step. The systems I described before can be put instead of the pure rhodium on top, and underneath you still have the platinum. So if you go instead for the pure rhodium now for the platinum as an intermediate layer, and then the rhodium-ruthenium on top, you will have a saving of 70% compared to the pure rhodium stack, and it comes down to a price of 84 euro cents. So this is a big step already. And if you go for the Rhodium-Platinum, which is 50-50 mixture in this calculation, you come down to 81 euro cents. So you have a saving of 71% compared to pure rhodium, with the same result for your client if he sees the jewelry. So this is the second level. You can have a saving, but there's a level more. Let us go to the level 3. What is possible in the saving steps? So now we come to the point, we still have the rhodium pure on our standard stack. Sterling silver comes to a price of €2.81 at such a thickness of 0.1 micron and 1 square dm calculated. So I said in the level 2, okay, let's replace a big part of the layer sequence with platinum, and we do the pure rhodium on top. So why to do the platinum in pure? If we can do a platinum-ruthenium alloy as an intermediate stack. The advantage is, compared to the pure platinum, the platinum-ruthenium alloys are higher or better in abrasive resistance, even that they are a little bit more dark than the pure rhodium. Nobody can see that under the layer of rhodium, and even if the first layer of rhodium would be wiped or scratched away, it is not visible if there's a scratch and a little bit more darker, still white color appears. Nobody can really see that or realize that there's a platinum alloy underneath the pure rhodium. Corrosion resistant is the same high level, and the quality of the same item is still high level platinum precious metal plating. And the saving step is here already at 70%. So you can do the same now in the combination of the rhodium-ruthenium as your final layer, which is a bit more dark but not really visible in the naked eye, and the platinum-ruthenium alloy underneath, where you have the big saving already. The stack is a bit more not so costly compared to the pure rhodium, and you have a full saving in that steps. You have 2 plating steps instead of 1 plating step for sure, but with this huge saving, it's always worth to go that way with this high cost and money you save on that. And last but not least, you can do the additional step. Instead of the rhodium-ruthenium, you do the rhodium-platinum on top, where we have the mixture rhodium-platinum 50-50%, and then the platinum-ruthenium underneath, where you have it flexible in the thickness, what you want to go, or how high the thickness shall be in the intermediate layer. And you do your whitest layer you have on top, regards on, or depending on if you want to go for the pure rhodium or want to have the additional saving, up to 75% is possible in that way. And for your the similar properties you get with the systems, as it's a rhodium or rhodium alloy on top, thickness is the same, the corrosion protection is the same. Visible for your end customer is the pure white rhodium layer or alloy. So this is the main thing I wanted to show you in the basic thing. What possibilities you have practically in your plating shop. So I want to go to an additional point, which is the replacement of palladium intermediate layer, because most of, if we go straight to sterling silver or silver casted jewelry, it is not just pure rhodium on top, but if you see in that column, usually it's the standard stack with sterling silver or silver And then you do a layer of palladium in between, as palladium gives you a really good migration and corrosion protection. So no copper or other compound of the basic alloy can migrate through the layer or come off on the upper layer on your jewelry. So palladium is a standard intermediate layer on jewelry. If you do the rhodium on top, the calculation you see now is just related to these intermediate layers. It doesn't is calculated with the top layer. It could be rhodium, but it could be gold plating as well. This is free to you what you do as your subsequent layer on top. It's just about the palladium. If you do pure palladium, then palladium price, like the rhodium price, shoot up really high in the last month, and it's volatile as well, and nobody knows where it will end in the price fluctuation. So palladium is a costly point as well and not predictable. So we have, let me say, to get rid of that as well. So the easiest way in that case is we go as well for an intermediate layer, giving us corrosion and diffusion protection, so nothing can migrate from the substrate layer or substrate material to the top layer. So the Platinum-Ruthenium is perfectly for this as well. It gives the same properties. In hardness, it's even harder, and corrosion protection is there. And at least like in the other level 3 I told you, if you do a plating on top, nobody can see the Platinum-Ruthenium in between. And if it's changed from palladium to Platinum-Ruthenium, it's a totally exchangeable what part you do. So instead of palladium, you use the platinum as an intermediate layer, and your final layer on top gives you a saving just in the palladium layer of 49%, because the palladium price is that high at the moment. So I talked mainly now as a reference or as some example about sterling silver. So what if you don't have sterling silver as your base material? All these plating systems in rhodium, ruthenium, platinum are highly acidic. And if you have, for example, not sterling silver, but brass or copper-based materials as your alloy, as your base material substrate, so you need something to have a barrier that while the plating, the acid is not attacking your base material. Therefore, you can do just the flash still of the pure palladium. So you keep your palladium, do the flash of it, and then your main intermediate layer you build up with platinum-ruthenium, and then you do your final layer on top. So you can do it even on bronze or copper alloys without an effect to your substrate. And you have the saving still of 44%, as you have to use a little bit of the expensive palladium. Another opportunity, if you don't want to do the palladium, you can do a flash gold as well. And if you calculate at the actual pricing, you get around 39% still in a saving compared to the pure palladium intermediate layer. It's still 39% and comes to 44 euros. So this is the way how to have your layer sequence to get these numbers of saving. So I will show you a little bit of product overview about this precious metal alloy plating, about this rhodium-ruthenium and the other alloy platings. So most of these platings are sulfuric acid based, as they come from the pure rhodium electrolyte. So the basic is usually sulfuric acid. And so far I can see the available products on the market are suitable in rack and barrel plating. So they give the same opportunities like with pure rhodium. And especially the rhodium-ruthenium electrolytes seem to be having a really good throwing power. So you can work in a wide current density range. So it doesn't matter if you work with low or high current or power, complex geometries like chains are really covered inside and outside, even and similar. So it's a good application in the decorative field as well as for the technical applications. The color is still white and bright and ultra shiny because of the ruthenium inside. It gives a really plinky and shiny effect, and because the layer doesn't matter if you are in low or high current density, layer thickness is quite even and similar, so you have a good uniform layer thickness, what gives you an additional saving. You don't spend too much on the higher current density rate, higher current density area compared to the low current density area in some inside areas. In this electrolyte, as I know, it's possible to go up to 1 micron. It's extremely abrasive resistant because this alloy of, in that example, 75% rhodium but 25% ruthenium, it's such a strong metal lattice that it's really hard, and you see that in the measured hardness. It's 600 up to 900 hardness Vickers available or reachable. The Rhodium-Platinum electrolytes are same sulfuric acid based. They have as well a wide working range. You can use them for rack and barrel applications, and mainly for decorative applications, possible wide and bright, up to 0.3 microns, as the platinum is a bit more, I would say, brittle than compared the mixtures of rhodium-ruthenium. So the final high layer is not, the reachable thickness layer is not so high. But if you see 0.3 micron is already for jewelry applications totally enough. So next slide I want to go. Okay, now it works. So the third electrolyte system I explained to you was the platinum-ruthenium electrolytes, which is same as platinum, is a sulfuric acid based or phosphoric acid based solution. So it's strong acidic, same wide current density range and suitable for racks and barrels. You can go up to 1 micron at this white and shiny layer. Even that's a little bit more grayish dark than the rhodium alloys, but it's extremely abrasive resistant and perfect as an intermediate layer. And you can reach hardness up to 700 hardness Vickers with that. So all these electrolytes give you a really good opportunity in cost saving, but additionally the possibility of to have layers which are abrasive resistant, corrosive resistant. So that means you have a higher quality in your plating compared to the pure metals plated, and this with a saving effect. So I want to go back to this first table I showed you. The actual prices at May 7th, so yesterday, the rhodium is about 226.65 euro cent grams per gram. So we have seen the last month terrific ups and downs of the rhodium pricing, and therefore I want to show you just January till May the development of the prices just of the rhodium. So in January we started nearly to 200 euros. It was going over 400 euro each gram, coming down, coming up again, and I can't predict where it goes, but it seems that this market is getting more and more volatile. So you cannot predict, you cannot estimate how much your plated rhodium will cost later on. So you need to limit the consumption of your rhodium in your layer. Your clients still ask you to have a proper layer, to have a good abrasive resistance and a quality, but in your layer itself, you can have a saving which will be directly your money you save in this with a better saving in that. So I want to show you what that means in a calculation. I don't know if you can see now my Excel sheet. So I put the daily prices of from January, February, March, and April in this list. So if you see especially the middle of February, the development of the pricing, so 400 euro and more was the development of the pricing in that time. So this means if we have a short look on the price development, and if you see in this calculation, I put 0.1 micron and all the prices of, I just delete this 400 for a second. So platinum, ruthenium, these are the prices at the moment, calculated alloys. And now the today's or yesterday's pricing was something around 226. So this is what I showed you in the calculations before in my charts and on my presentation. So here you see the layer cost of rhodium about 226 euro at 0.1 micron at 1 square meter. Platinum much more cheaper, and so on and so on. But this pricing we had in February, and I changed now the pricing to 400 euro. So if you see, it changed to a pricing of around 400 euro in the pure rhodium, and the comparison here, it's going down. So the saving, if you go for an alloy, is much higher. This you can see on these layers. I put in, for example, 1 kg of consumption. 1 kg of rhodium is costly at these 400 euros, costs 400,000 euro, 1 kg. Comparing platinum, pure 350,000. If you go for the Platinum-Ruthenium, it comes down to a pricing of, let me see, 42. And so the saving compared to rhodium to platinum, the saving would be 358,000. But pure platinum is not that wide in color. So the alloys, Rhodium-Ruthenium, give you a saving already from nearly 100,000 euro. The Rhodium-Platinum, a saving of 130,000 euro, just by changing one plating electrolyte to the other. So this is a short thing I wanted to show you as well. Finally, this is what I wanted to show you and explain you and give you an idea what is possible nowadays. And I'm free for questions on these topics, and I want to say thank you joining this show, and hopefully you get some ideas and developments with that. Thank you so far.
Thank you, Mr. Joachim. We will now move on to a question and answer session. I'd like you to take over.
Mm-hmm. So I have seen there were some first questions already before I started the presentation. It's quite funny, but the really first question is a general question I see quite often in the plating industry, which is from Mr. Ravindra. Apart from the chemical test, is there any technology to sense precious metals in bath? So I want to answer this very easy. Nowadays, you can do electrolyte analysis not just with a chemical analysis in a lab, but with X-ray measurements of the solution itself. The latest X-ray machines can do that. So you can have at least a rough number of your metal compound like gold, silver, rhodium, platinum in your plating solution. So this makes it much faster and easier to have a rough idea in your production. So what is the next question? Next question is, how durable is red or green rhodium, and does it have good life? What I see on the market, the only available technical applications for such kind of rhodium is a very, very thin layer of rhodium. Because this color effect comes just by the interference of the light, because the layer is not fully getting a thick layer, so the light is reflecting and shining in bluish or greenish colors. So what does this mean? It's a very, very thin layer. So this layer can never be long lasting from my point of view. And the point is, you can't not even protect it with an, let me say, like a lacquering or something else on top, as this would destroy this. So it doesn't matter if you do a saving on top, so it will not be helpful. The next step, I would say. So what are you saying is that an alloyed plating will work the same? Will it have the same wear tier, same look? How will it affect the caratage of gold? So I can say that the alloy plating works the same. You have your setup with your tank, with your anodes, with your rectifier. Power on plating, like you do with the rhodium as well. So this is really the same. There may be some different parameters to adjust, like temperature, current density, or voltage to apply, but you don't need a specific order setup. The wear resistant at the most of these alloys are even higher than the pure rhodium or platinum. So it gives you a better quality and wear abrasive resistance or hardness, and it will not affect the caratage of gold. As if you have, for example, a casted gold item and you blade on top with 0.0 micron rhodium, this caratage in total is the same if you have 0.01 micron of rhodium and 0.09 micron of ruthenium, as an example. So it's still the same ratio. Most is the gold, and the final flash plating on top is the rhodium or a rhodium alloy. So the caratage will be the same. The next question is, how easy to maintain the bath of rhodium and ruthenium compared to a pure rhodium? It's always best you have the opportunity to have an analyze, like in the rhodium, if you know how much grams of rhodium is inside, to be on the safe side, have always same rhodium, gives a good plating. The same here, rhodium and ruthenium. If you have the proper ratio, you get the best result. The good thing is, even that you have different levels of rhodium and ruthenium, if you blade out a little bit too much of rhodium, the ratio will a little bit be balanced, and with the next step you blade a little bit more out of the ruthenium. So the compounds, rhodium, ruthenium, is always balanced in the same level, so you cannot fade out or run out. And even if it starts to get too much rhodium, for example, so what means it's more pure and more white, you can work against that by lowering the power by plating. And if you have it too grayish, you put more power, you blade in more rhodium, and it is balanced again. So it's really at least 2 points, 2 screws to fix to keep it balanced. Next question, is there any ready solution in market for cheapest combination of platinum and rhodium? If I understand this question right, it's a question about this rhodium-platinum mixture. So it is available at chemical suppliers, plating chemical suppliers. You have to check with your local supplier of the chemistry if they have it available. But I know different suppliers having this chemistry. So I work for Umicore. I know that we have it. We can supply this. The next question is about what is black rhodium plating. Black rhodium plating, so the pure black rhodium plating is mixture out of the rhodium layer is not totally fixed metal lattice, which gives a clear structure, but an amorph, so a chaotic plated layer. So the light cannot easily reflect like with a mirror, but it's diffuse going away, so you have not a clear view on it. So this brings the light dark, what means it is not a white color, it is a dark color. Additionally, it is possible to mix some compounds in to make this effect more strong. And additionally, I know from others try to put in some pigments to make it dark as well. Okay, so Mr. Mayank Goyal, sorry, I mean platinum and ruthenium. Yes, platinum, ruthenium, same available on the market to do it as an intermediate plating. There are clients around the world doing this plating even since 10 years and longer with the platinum, ruthenium, even as final layer as a replacement for pure platinum. So this is possible as well. If somebody has applications in pure platinum, you can go for the platinum ruthenium as well to have a saving in the metal of platinum, which is expensive. But additionally, you have what want I say? You have a layer of platinum ruthenium, which in hardness and abrasive resistant gives you a better quality compared to platinum pure. Question, is this replacement theory? Actually, it's not a theory, it works. Over 10 years, international fashion jewelry brands do this kind of plating on their jewelry. That is not fancy new theory, it's really working, and you can buy it in the shops. Pen rhodium, so alloy plating, so far as I know, it is not yet available in mixture plating. But this is the status I had from the last couple of months. So maybe in the meanwhile, it is available. You have to check with your supplier if this is possible to get already. For my information, not yet. So is the rhodium-ruthenium available for gold plating? Of course. I said sterling silver just as an example, as a base material, as a jewelry base substrate. You can do it on all kind of gold plating as a white gold on top as well. No issue, no problem, that works. The next question, how can we use the plating to mask the microporosity on the surface of 3D printed platinum jewelry? This is in fact a really tricky thing, and I have seen a couple of trials in plating on top of 3D printed master jewelry pieces. So far, I see the problem that with the microporosity, let me say it's like a hole, and you plate on top with acidic plating like the platinum or rhodium and so on. You would just cover it and it's dangerous that you put some liquid inside what comes off later on. So to cover 3D printed jewelry, I would recommend an intermediate layer which is really filling up the holes, that you don't have some agglomeration or pinholes or something like that. So at the moment, I would not recommend to do such kind of alloy plating on such 3D printed parts. But on the other hand, it's worth to do a trial to see if it works. So I always welcome to, let me say, crazy ideas to do a trial with that. I'm open for that. So we can get in touch later on to discuss this point. From my side, really welcome. Thank you, Rutesh Shah, for this question. So one more question I have: how often do you need to rhodium plate a jewelry piece? If a final piece is sold and the client is using it, wearing it, there will be a point where the layer is wiped off, scratched off, and so on. And this depends on, of course, what is the client doing with the jewelry, but this you will never know. So that means you need to do the best quality selling to your client. Points what can have a longest lifetime is high thickness, highest hard plating on top, which gives a really good wear resistant. Just in the examples I showed, the Rhodium-Ruthenium gives a really high white shiny like the rhodium, and it gives in the 75 to 25 relation or mixture ratio around, and this is a rough number, about 50% longer lifetime or abrasive resistant compared to pure rhodium plating. So this is again a question: are you talking about plating on silver or gold? Doesn't matter, it works on both. All the sequences are possible on silver or gold plating or whatever you have as a substrate. Even if you have copper or brass or bronze, like I explained, where you have a flash to keep it safe, the plating can be done on top. So again, such a question: should we implement this theory on gold products during rhodium plating? If you do rhodium on gold, you can do this alloy plating on gold as well. So it's totally interchangeable, whatever you like, which kind of system you like, it works on top of the gold alloy, same like on silver. Again, a question to what significant difference occurs when using pure rhodium layer or this mixtured rhodium and platinum layers. Quality-wise, you get a higher hardness, higher abrasive resistance. So it is a benefit for you in money and a benefit for you client in higher abrasive resistance, what means a longer lifetime. So there is no disadvantage in that, just that you have to have the auto plating solution to get the result out of it, and then you can apply this better quality, high quality layers on top. So question about the deposited color of Rhoduna alloy or rhodium. I explained on the first step where you see a pure rhodium plating nowadays reaches an L value of around 90 in whiteness. The Rhoduna alloy, if you have a mixture 75 to 25, is about 89. So it's so marginal difference that a client in the jewelry shop never ever can see a difference in that, and you are free to change the alloy composition. You can go for 90 to 10 or 75 to 25 or even lower. But if you have more ruthenium in the layer, with the time, the layer will appear darker. So with 75-25, you reach a good saving with still a white layer, which is totally comparable to a pure rhodium layer. The bonding strength, in the way I don't know the numbers of Newton in a peel-off test, but it is absolutely no problem to plate platinum, rhodium-ruthenium, platinum-ruthenium with rhodium-ruthenium. All these layers sequences I described are totally interchangeable. If you do in your job shop plating, rinsing, and then the next plating, it fits to each other and it sticks to each other. There's no problem in adhesion if it's properly pre-treated and activated. So how can the layer thickness check that such various layers such as rhodium, platinum, gold, and so on? The latest X-ray machines are able to measure the alloy composition and the thickness if the application on the systems are adjusted to that. So you have to check usually with your supplier of the XRF machine that they set up the additional elements, like if you had pure rhodium and now you have rhodium-ruthenium, you have to ask them to set the ruthenium in the calculation in the software that the calculation can be done. Like if you have a gold alloy and not a pure gold, where you put in other elements to get the proper caratage or the proper mixing ratio of the gold alloy out of the XRF machine. Here a question, do the cyanide-based bath not give the best whiteness to rhodium plating? Honestly, I have never seen a cyanide-based rhodium plating, as the rhodium is on the market available in mainly rhodium sulfate, rhodium phosphate, concentrate on basic chemistry, and all the chemical suppliers work with these basic solutions. I have never seen alkaline or alkaline cyanide based rhodium plating. So one question, can one use platinum rhodium layer on white gold? I guess as replacement of rhodium, yes, it works definitely. Platinum rhodium is more or less the same L value and shine like the pure rhodium, so your client will not see the difference on that. And it's like I explained before, on gold alloy is possible to plate the rhodium platinum on top. It is, the adhesion is there and it's no problem. It's the same plating sequence like if you would do it with the pure rhodium. Okay. So how to remove impurities from the running bath? If you have, for example, organic impurities, what comes from pretreatment and other platings surrounding, organic removement can be done by active carbon treatment. So it's an easy handling and not magic. That is well known. Works in rhodium-ruthenium, platinum-ruthenium, rhodium-platinum as well, like on the pure rhodium, like you are used to that. So there are coming more and more questions in. I would say so far, I will go through these questionnaires later on. there are a lot of double or 3 times the same kind of questions. So I thank you for all the questions. The team will collect the questions and hand it over to me so I can reply to the emails in the next day, and hopefully I can manage all of them because it's getting more and more. So really thank you for your interest in this presentation and to know about this alloy plating. From my side, really thank you for watching this and listening to me, and thank you for GemAtlas giving the opportunity to spread out this information. So I, from my side, wish you a nice day, and again, thank you and a good time, and all keep safe and keep healthy. Thank you.
Thank you, Mr. Joachim, for sharing your valuable time and expertise. We also would like to thank the audience for an active participation throughout the session. We hope you enjoyed the session and use this knowledge to your advantage in your respective businesses. If you have any further questions, you can email it on info@gematlas.com, and we will forward the same to Mr. Joachim. Our next webinar is with Ms. Larissa, who is the founder and creator of Joy Joya from the United States, and will discuss planning your jewelry marketing strategy, which would help you lay a marketing foundation and be prepared for when consumers are ready to buy. She will also be talking about predicted shopping habits once this pandemic is in control. Hope to see you all there. Thank you and have a good day.